many very advanced algorithms to cope with the complexity of the scene, because there's many pedestrian-like objects, and most active sensor cannot distinguish between that, the pedestrian, that box, and many other things within this very complicated scene. And pedestrian detection will work at variety of scenes. Also, that's a more US area. The previous one, by the way, was in Japan, where you have the tendency of people walking on road in some of the older part of the big cities. That's a more US clip, where you'll have many people on the side, you'll drive at slightly higher velocity. But again, the thing which is very consistent is that the technology is robust. Honestly, the one thing I'm mostly proud, where others have said about our technology, is that lately there was a big conference at MIT where they talked about where artificial intelligence had went so far. And then one of the leading artificial intelligence researchers said, in some aspects we're not that happy with the situation, because although there is Deep Blue, which probably it's the first, probably many of you have heard, it's the first computer software which beat the world chess champion. There's Jeopardy, which did the same for Watson, sorry, which is the same for Jeopardy, and there's Mobileye, which did the same for computer vision, in the sense that it's proven that what was considered to be done by human can be done by machine vision. And as I said, pedestrian detection is one aspect. Vehicle detection is a second aspect. And again, we're overlaying the system output on the image. Of course, by the way, that's not what a driver will see. Eventually, this information is used for either warning the driver or controlling the vehicle or doing other things. But the heart is the ability to find the object, know which of them is relevant, that's the one we mark in red here, assess the distance, the relative velocity, the time to collision with that object, analyze where there are lane marks, and use all of that information to help the driver. I'll skip that slide. One example of another technology we have is traffic sign recognition, and that's a video which was made by BMW when they have launched in 2008. The first product doing traffic sign recognition with other things in parallel, and it's done based on our camera technology jointly with navigation information for places where you don't have signs but still you need to drive at a certain velocity. It works very well, and it gives the drivers the information of what's the allowed speed limit. Leslie. Thanks. And this information, and the technology works at very high reliability, 98, 99% in most countries. I think in France it's somewhere also close to 99%, very high precision. And we have extended it from just speed limit signs to other important signs, and we're on an ongoing process of adding more and more functionality there.
Excuse me. What's the difference between Germany, France, or other countries related to the percentage of success?
Multiple reasons. One reason is in some places in Europe you have very small signs or very problematic electronic signs, which we cope very well with, but it's more challenging. The second reason is that the system not only detects the signs, but also detects the small signs one has many times below the sign. And those change between countries. And with traffic sign recognition, some of the complexity is the fact that you need to collect data to train your system from various places to cope with all challenges. Okay.
What's the definition of the sensor to be able to read such instructions?
Sorry, what's the
The
definition?
definition, resolution.
Resolution?
Resolution,
Oh.
sorry.
We usually demand to see something like 10 pixels from a sign in the image, and the imager we currently use is in many aspects quite close to almost a blind person. It has just VGA resolution. It's
Oh,
not
okay.
very high resolution. The product will have in 2014 on has 4 times this resolution, 1.3 megapixels.
Thanks.
And just to give a ballpark understanding, we managed to detect a vehicle detection at 100 meters with VGA resolution, because you can compensate for the cost of the imagers by using very sophisticated algorithms. And 2 additional examples. That example is showing the challenges in automatic high beam control. Eventually what one wants to do is, when you drive in dark area, be at high beam all the time, and when there's a vehicle coming or any other things where you must lower your lights. I'll play it again. It will automatically switch to low beam. What we have here is we are marking that we have seen the headlamps of a vehicle, and based on that we'll go to low beam. The basic application just does the binary thing, and the more advanced things getting out into the market this year, next year, and the following years use the fact that the headlamps become more and more complicated, and then at various areas in the world you'll be at high beam, at other you'll be at low beam, and this way you maximize the portion of the time you are driving with high beam on. The next technology is lane analysis, and then you can see the type of challenges. There are many other lines due to shadows and others which are not lane marks, and one needs to find the correct lane marks in the scene. I'll play it again. I think that was taken in Jerusalem. You may have drove through this road. It's the Begin Road, and it tends to have those shadows. We had that in production already for 4 years, from 2007. Multiple car manufacturers, and there are many other nice technologies, things related to lane analysis. For example, one can know how many lanes there are. You can say, I know that there are 1 or 2 more lanes to the left, 2 in this case, 0 to the right. And let's say when you merge it with your navigation, if you need in 500 meters to turn right, and you're already on the right lane, it will wait and tell you only 200 meters beforehand. But if you're at the leftmost, the system will know to tell you in advance to improve your driving style. Or the technology has to cope with challenging roads with many curves and other stuff. And again, in those roads, it's really nice if the car can help you stay in the center of the lane with so many things disturbing you from doing what you ought to do and just driving. So the system has to cope with the challenges of the far from trivial road structures as part of the technology. I think I already stole a lot of time, so I'll stop here. There are many other interesting technology stuff we're doing, and if you have any question, I'll be happy to answer.